Alright guys, so now we're going to look at a process called Gaussian elimination. Okay, it's another way to solve a system. Mainly you would use it for a 3x4 system whenever you have three variables like an x, y, and z that you're solving for. But you can do it on a 2x3 where it's just x and y, but we'll probably just use it for a three variable system. Okay, so the goal of Gaussian is to bring an augmented matrix, and I'll tell you what that means in just a second. So to bring an augmented, basically that's the matrix you start with, and I'll label it for you whenever we go to an example, to an upper triangular matrix. Okay, and I'm going to go ahead and draw you a picture of what the upper triangular matrix is going to look like. Very vague. Okay, so basically what it's going to look like is you're going to take your initial matrix, and your goal is for this to be a diagonal right here of constants. Okay, you'll have a line and some other numbers over on that side. Okay, but on this left side, three numbers in a line like this, in which beneath those constants in these three positions are zeros. Okay, and then the rest of these are all constants as well. Okay, but the reason why it's called an upper triangular is because, see, along this diagonal in this upper corner makes that triangle. Okay, so hopefully that's a way to remember it. What your goal is to get these three positions to be zeros from whatever you start with. Okay, so we'll look at an example. Okay, and I would just say bear with me through it. Okay, you can pause at any time. Okay, let it soak in, like what did I just do? Okay, because once you get the hang of it, it's not too bad. It's just seeing it for the first time. That might just take a second. All right, so here's your three variable system. So remember, you're on a 3D plane in which all three of these are intersecting, and you're trying to find that point of intersection where the three planes intersect. Okay? All right, so your first step is to take this and write it as an augmented matrix. So that vocabulary word we first started with here. Okay, and basically what that is you're taking the coefficients from these three equations and putting them in a matrix. Okay, so just make sure you have an x column, a y column, a z column, and then a constant column over here. Or whatever's on the other side of the equal sign, however you want to label that, okay? It doesn't always have to be x, y, z. It could be a, b, c, whatever three variables you're working with, okay? But just for this example, it's x, y, z. You just got to keep them in order, okay? So the coefficient here is 1, 1. Make sure the sign always goes with the term that follows, so that'll be -1, and then your -2. Okay, we use a line to separate, kind of like the equal sign, to represent the equal sign right there, and then you put your constant to the right of that. Okay, so then we go 2, -1, 1, +5, and then your last row, -1, +2, +2, 1. Okay, so this right here is called your augmented matrix. So we're taking this and trying to turn it into an upper triangular matrix, so meaning we got to get these three numbers to get to be 0. Okay, so here's the fun part. You ready for this? Okay, we can manipulate these numbers here, which remember are our equations, okay, through either multiplying and then adding or subtracting your rows together in order to get zeros here, okay? So the reason why you're allowed to do that, because if you multiply, let's say I want to multiply this top equation by 2, for example. As long as you're doing it to each of these terms on the left side and on the right side, it's keeping that equation balanced. So that's why it's legal, okay? So we're going to start here with my augmented matrix. And my first task, okay, you're going to always want to look beneath this first number, this upper left number right here, another word coming at you. It's called a pivot, and actually 2 of our numbers will be pivots in each of these problems, okay? But you're going to always start with the upper left, okay, and you work down. So you want to get the numbers underneath, so these 2 here to be zeros first, okay? So what you have to do is look at your rows, okay, and think, okay, if I need this to be 0, what could I multiply this top equation by in order for it to cancel? Okay, so if we have a positive 2, think about 2 plus what would give me 0. Okay, hopefully you're thinking negative 2. Okay, so 2 plus negative 2 would give me 0. So what that means is I have to multiply this pivot by something to make it that negative 2 so that they'll cancel. Okay, so how we write that out is I want to multiply my row 1 by 2, okay, the coefficient, or negative 2, in order for these to cancel. So I'm going to say, I'm going to take negative 2, multiply it to row 1, okay, so I can write, this is like row 1, row 2, row 3. So you kind of just make little notes to yourself over here, okay? So I'm going to multiply negative 2 by row 1, and then I'm going to take, once I multiply each of these by negative 2, I'm going to add that to row 2, because remember, if I do multiply by 2, or negative 2, that's negative 2. And then if I add that here, negative 2 plus 2 is 0. And that's what we want. Okay, so we're just kind of making a short little hand notation over here. And that's going to result in a new row 2. Okay, so again, just kind of watch it happen. So we're going to take negative 2, and as you get better at these, you're not going to have to write out everything I'm about to do down here, but since it's like the first time you're seeing it, I'm going to be very detailed. But just know that I know some of you are going to get fast at this, and you're not going to need some of these steps, and you're going to be able to do it in your head, and that's okay. Just don't miss that. Okay, but I'm going to write it all out for you here. Okay, so my first step is I'm going to take negative 2 and multiply it to each of these constants in row 1. Okay, so negative 2 times 1 is negative 2. Negative 2 times 1 is negative 2. Negative 2 times negative 1 is positive 2. And then negative 2 times negative 2 is a positive 4. Okay, so that's row 1 all being multiplied by 2. Negative 2. Oh my gosh, I keep dropping that negative. Okay, make sure you're multiplying by negative 2. Okay, so then we're going to add it to row 2. Row 2 didn't need to get multiplied by anything because I was able to multiply the first row by something to get these to cancel to 0. There are times you have to multiply both rows by something in order to make that happen, but not here. Okay, so we write it exactly how we see it. So 2, negative 1, 1, 5. And we're going to add those together. So negative 2 plus 2 is 0. Like, that was the whole point of multiplying by negative 2. That was the whole point, is to get that number to be 0. Negative 2 plus a negative 1 is negative 3. 2 plus 1 is 3. 5 and 4 is 9. And I like to make a little note to myself. This is my new R2, right? That's what it resulted in. So that's what this is. Just because then when I come over here, I'm going to bring down my matrix. Okay, I'm going to rewrite my matrix. I'm going to write my first row because we didn't do anything to it. And then I got to write my new R2 in R2's spot. So it's kind of just a little note. You don't have to necessarily do that, but just to keep organized, I like it. So I don't forget to change out those numbers. So that basically came up here. And then row 3 stays the same for now. And again, as you get better at these, you can do like row 2, manipulate that to get a 0, and manipulate row 3 to get a 0 here. Like, I realize you're going to be able to do that eventually, but again, just kind of giving it to you step by step. Okay, so now we have a 0 here. Okay, so we can put a little check in our brain. We got the 0 here. Now we need a 0 here. Well, look how cool this one is. So since we can add, subtract, multiply in order to get combine our equations to get them to 0, notice if this equation 1 and equation 3, it already has the same number opposite sign. Keep that in mind, that's going to be helpful. Okay, so that's going to add to be 0 when you have the same number opposite sign. So keep that in mind for like a strategy. Okay, so what I can do is I don't even have to multiply either of these equations by anything. It's already set up, ready to go. So I can take, here's my little note, I can just take row 1, okay, that was a really bad R. Okay, row 1, again, that's here. And I'm going to take row 3, which is down at the bottom. I'm just going to add those together. And that's going to result in my new row 3. Okay, so I'm going to write row 1 as I see it, because I don't have to multiply it by anything. So 1, 1, negative 1, negative 2. And then I'm going to write row 3 exactly like I see it. So negative 1, 2, 2, 1. And I'm going to add those together. So 1 plus negative 1 is 0. Exactly the whole purpose of why I'm combining this, because I needed that position to be 0. 1 plus 2 is 3, negative 1 and 2 is 1, and negative 2 and 1 is negative 1. And again, I just like, even though it's here, like I realize that, you're like, oh, it's right there. You've made a note to yourself already. Okay, I would just like to do it again as like an extra reminder that's your new row 3. So whenever I bring down my matrix, okay, row 1 stays the same. Row 2 stays the same. And see, that's wrong. New row 3 goes there. So 0, 3, 1, negative 1. Okay, so once we have that part of the matrix, notice everything beneath this pivot is now 0. Okay, so what that means is we have to change our pivot. So our next pivot comes from this number here. Okay, so or that position. It's going to be a different number because we've manipulated our equations. Okay, but that position is our new pivot, because if you look back up here to our goal, okay, this was the pivot and all zeros underneath it. That's why it's called that. Now this number is going to be the pivot. It needs a 0 underneath it. Okay, so this is our pivot. So what that means is the number underneath it, we have to get that number to be 0. Again, so convenient. Hopefully you're noticing that these are the same number, opposite signs. So automatically those are going to cancel to 0, which is what you want. Okay. If they weren't, you would have to multiply one of the equations by a factor in order to get it to cancel like we did the very first step. So here, my note to myself is I'm going to take R2, row 2, and I'm going to add it to row 3, and that's going to result in a new row 3. So I'm working with these two bottom ones. Okay, so I'm going to write them as I see them because we didn't have to multiply by anything. So 0, negative 3, 3, 9, and then 0, 3, 1, negative 1. We're going to add those. So 0, 0, that's what we wanted, 4, 8, and that's our new R3. Alright, so now we bring our matrix down. Okay, so row 1 and row 2 are the same. So 1, 1, negative 1, negative 2. 0, negative 3, 3, 9. And then the new row 3, 0, 0, 4, 8. Okay? And then you would just want to make sure, if you want to like, draw a line through these, or like around it, where that becomes your triangle. Okay, that's again the triangular matrix. That's what we're talking about. And then underneath that are all zeros. You're good to go to create your system. Okay. So that was our goal, but we're not done yet because we still have to solve. Remember, our original problem would be to solve for the intersection point. So we're looking for the x, y, z coordinate of this system. But we can use this new matrix in order to help us solve. Okay, so we're going to basically take this and rewrite it into a system format. Okay, so these are the coefficients of our variables. So again, they're the coefficients of the x, the y's, and the z's, and these go on the other side of our equal sign. Okay, so now we're going to make a system. I'll write it here and I'll solve it on it. Okay, so there's our system. Okay, so this is like 1x, 1y, but we don't have to write those, right? We can just say x plus y minus 1z, or minus z, equals negative 2. Our second equation comes from row 2, so you could put 0x, but 0 times anything is 0, so not necessary. We can just put negative 3y plus 3z equals 9. And then our last equation comes from right here, so it's just 4z equals 8. Okay, so that would be our new system that we're going to use to solve. Now, hopefully, and I bet some of you are already doing this, okay, you're seeing that 4z equals 8, you can come down and automatically solve for z, right? Divide by 4, divide by 4, so now we know our z coordinate is 2. And that's why putting this into this form makes it super easy, because now you can just do substitution up the ladder, because now you know what z is. We can substitute that into equation 2. So I can take negative 3y plus 3z equals 9, and I could sub that in for z. Okay, so on a mission to solve for y, so negative 3y plus 6 equals 9, subtract 6, and we go through this part kind of fast. Okay, so y equals negative 1. Cool? Okay, so now you have your y and your z. Now we go up the ladder and we plug those in to x plus y minus z equals negative 2 in order to solve for x. Okay, so x plus negative 1 and then minus our z, which is 2, equals negative 2. Okay, we can go ahead and combine these. So negative 1 minus 2 would be negative 3. And then add 3. So x equals 1. Boom, and you're done. Isn't that fun? Okay, so now you have to write it as an intersection point, just like you would an xy coordinate of a system of 2 variables. You're going to write it as an xyz coordinate as your final answer. So 1, negative 1, 2. You did that. How exciting. I'm sure you're smiling right now.